Hello, welcome. My name is Greg Braille. I'm here also with Keith Danikind. And together, we're going to talk about APIs and how people use APIs to create connected digital experiences, to create new lines of business, new product areas, new things out of APIs and out of all kinds of technology. We're going to start out with some examples about how people actually have used APIs to solve real business problems. Then we're going to talk a little bit about sort of what this means by showing you a demo of what it means to be a consumer of an API. Then we'll go into some more detail about the technology. And after we do that, we're going to have another demo, which is going to show you how you actually use Apogee in order to actually create and manage these API programs. And finally, we'll have time at the end for questions. So if you do have questions, I know there's ways in the tool that you can actually do that while we're talking, and we'll be getting to those at the end. So don't be surprised if we don't address them right away. So I wanted to start off by talking about interesting things that businesses have done around the world, primarily using APIs. And there are some really interesting aspects here. So for instance, if we look at Starbucks, they put in their annual report that 13% of their revenue comes through mobile apps. Those mobile apps are not built on completely new technology infrastructure that never existed before, because Starbucks has a big infrastructure already. Instead, what they did is they used APIs, and the mobile apps talk to APIs, and the APIs then give the mobile apps just what they need to give a really good user experience to those apps based on Starbucks' existing technology. Other examples, for instance, are Swisscom, which has actually been offering APIs as a service for some of their network infrastructure in Switzerland, or Arity, which is part of the insurance business. It used to be in order to bring a business partner on board, they would have a 3 to 4 month process of negotiation, emailing, Microsoft Word docs, all that kind of fun stuff. Now with APIs, they allow their business partners to get on board with their business-to-business services within a few days, completely within self-service. And we'll talk a little bit more about why that's important and why that's a big part of everyone's API programs. The way people use APIs and use API management, because this talk is also going to be a lot about API management and what it means, is we've been doing this for a while. I've been part of Apogee since 2007. We weren't talking about APIs back then, but we started soon after. And a lot of customers who come into this world of APIs and API management, they start off with sort of a point-to-point problem, like, my goodness, we need to launch an app for iPhone and Android, and we don't have any technology in our existing system that can actually talk over the internet to those devices. How am I actually going to connect these mobile devices and all these kinds of things to my legacy systems? And that's where we started to see, 5 or 6 years ago, people doing basic web APIs with API management, using API keys in order to protect access to an existing service, implementing things like OAuth, putting things like Quotas in place in order to protect access to the internet. But where things have gotten really more interesting recently, and the companies that have had the most interesting successes with APIs, are people who are creating differentiating digital experiences. That is, people are creating new ways of doing business, not only through mobile apps, but through things like digital assistants, which we see all over the place nowadays. And the real fun comes when people are able to actually transform their business models and create new ecosystems and turn their companies into platforms that other people can do business on. And I'm going to talk about a few examples of those. A great example here is Magalu. If you're not familiar, they actually used to be called Magazine Luiza. They're the largest retailer in Brazil, and they have been a brick and mortar retailer for a very long time. And what they've done over the last few years is they started to change into more of a platform that third parties use to do commerce in Brazil. They obviously have a huge infrastructure. They have a huge physical infrastructure. And they started off with that basic task of creating new digital experiences. Hey, we need mobile apps. We want to be able to offer e-commerce. But it quickly pivoted into actually now they have about 100 APIs, but they have thousands of partners and suppliers who use their platform to do things like sell products using their infrastructure, ship using their supply chain. Very much like Amazon in the US became not just an online store, but a platform for e-commerce that thousands and probably even more producers and consumers use to transact business. Magalu is doing the same thing in Brazil. They're sort of becoming the Amazon of Brazil, which is ironic because Brazil already had one of those, but now they have a digital one too. Another great example is AccuWeather. Everyone knows AccuWeather because, some of us still watch TV sometimes, and our weather information, also our weather information on our various mobile apps and things and on the web, comes from AccuWeather. They have a well-deserved reputation for giving excellent weather forecasts. They process about 50 billion API requests a day, and the vast majority of them are from the weather app on your phone or your watch or your refrigerator or whatever, right? But what AccuWeather also does is they have some high volume forecast products, because long-term weather forecasting is very important in a lot of industries, financial services, oil and gas, agriculture. These depend greatly on long-term, very accurate weather forecasts. That's what AccuWeather is known for. And those forecast products are pretty valuable. So AccuWeather has whole tiers of APIs, and they have ways in order to bring business partners on board with those higher value APIs to actually charge them the value of that interesting data that they're giving them, and also to keep track of who's using the API. And one more example is Ticketmaster. We all know Ticketmaster because that's where you go when you want to buy a ticket. They, of course, have a mobile app and a website and all those kinds of things. But they also, one thing that not everyone knows is Ticketmaster actually offers APIs that allow third parties to transact business and to buy tickets on Ticketmaster. And in 2016, actually, which was a little while back, but 10% of their ticket sales came from those partners. And some of those partners are things like Costco. Hey, buy tickets at Costco. But there are other aspects where people have integrated Ticketmaster into apps. So for instance, you just bought plane tickets somewhere. Would you like to buy tickets? You bought plane tickets to New York. Do you want to go see Harry Potter and the Cursed Child while you're there? A travel app for a travel site, for instance, can now use the Ticketmaster API to integrate that directly into their app without jumping out to a completely different digital experience. So what kind of holds all of these together is that all these various companies are not only using APIs to solve business problems, but they're not looking APIs purely as a bit of technology. They're looking at the API as something that is for a customer. They're looking at it as a product. And I think that's where things get really interesting. And that's where APIs get really successful, is when you don't just think of it as, how are we going to get the technology to get the JSON to the mainframe that's going to look at the XML and talk to the SAP, but how are we actually going to create something that developers are going to want to use? So for instance, Magalu deals with retail partners. So their API product managers, and big successful APIs have product managers, have to think about questions like, what kind of technology do these retailers use? What data formats can they handle? How are they connected to the internet? What sort of things do they need to do in order to actually access these APIs? Similarly, AccuWeather, Ticketmaster, and we all, we've all been there. Most of us are developers, or we've developed software, and we know what we like and we don't like. And what I've always said about developers for a long time is that developers aren't lazy, but developers are in a hurry. And they have a very, very fast way of telling by looking at something. Is this something I want to engage with? Is this something I want to spend my time on? Or is this something that's completely off in a different direction and is going to be a waste of time, or is going to have to require me to pull in a bunch of technology that I don't actually need? The great thing about APIs is that it was based on a very, very simple technology base of HTTP, JSON, OAuth, TLS, technologies that are already prevalent anywhere, so that a developer who wants to learn to do an API doesn't need to install a giant tech stack, but can actually get started right away using technology they probably already know. So what we've seen between projects and products is that it's really about even looking at things like, what is your revenue? What is your CSAT for your API? What are your lead generation capabilities? Is there someone who's looking every week at how many people have signed up to use the API? How has API traffic changed over time? Have new people started to come on board? Have people who have been customers before stopped using the API? There are a lot of interesting things that have to happen there. It's just like running any other digital product. And with that said, we're actually going to start with a demo of what it looks like to be a consumer of an API. What does it look like to discover an API, look at the documentation for the API, sign up the API, and get started? So Keith is going to show us his demo system right now.
Thanks, Greg. Okay, so for the demo, we're going to look at this from three different perspectives: the application developer, the API developer, and the API team. So the application developer, or API consumer, might be saying things like, all I want to do is build an application. Make it easy for me to consume your services. The API developer, who's taking services and packaging them up so that that application developer can use them, that person might be saying, I need to share a service with other people, but there's some limits. We have to control what they can do. The API team who's running the API program, they may be saying something like, I want to think about APIs as software products. There's customers, there's life cycles, there's versions. I want to measure my program and I want to tune it. So in this case, I'm going to play the role of the application developer or API consumer. And in this case, one of our suppliers has a large ERP system, and we place orders with them, and we'd like to check on the status of those orders. And this is a somewhat time-consuming process right now. They've granted us an API to be able to go speed up that process and automate this and to integrate that information into our internal tracking applications. So let's see what it looks like to use the order management and order tracking APIs. So here's their developer portal. And what I want to learn about is how to track the status of an order if I have an order number. So let's see what they have here. Get started, get a key and test out the APIs, learn about and try our APIs. So, well, how do you get started? Get started in 3 steps. Sign in, register apps, access the API keys. Okay, that sounds easy enough. Let's see what the APIs are. Looks like there is a order status tracker here, and someone's written some nice documentation to make this easy for me. So I call a URL, I put an order number at the end of there. I'm going to need to supply an API key and an order number, and I should be able to make this work. I'll get back some data that looks like this, so that's pretty good. I have a reasonable idea of how this might work. I'm going to go register for an API key, and I'm going to test this out. So I come over to here, and I'm going to click on Apps. I'm going to register a new application. And we'll use this order tracking API. When I create this, it'll register my application, and it'll give me an API key. So now that we have that key, let's go back to the documentation and try it out. I'll put the key in there. We'll grab a sample order number. And there we go. That's what the results look like. So I see the data's in here, and that's what I would expect to be returned when I call this API. Easy enough to do. Let's build an application. So here's a simple order status tracking application. You put an order number in here, press search, and we get back some status of this order. So we get all the details there. Very easy to write this. Took me about 15 minutes or so. And best thing was, I didn't need to have any knowledge of what's on the back-end system, how this order system on the other end works. I just had a simple API to call, and it returned that data. I built a single-page web application and put it in here. It'd be easy to embed this in any kind of application. So that's the demo from the perspective of the API consumer or application developer. Next, let's look at this from the API product manager's point of view. What is it like to manage this API program? So let's see how our API program is running. To do that, I'm logged into the Apogee experience. I'm going to come over and click on the Analyze button. And from there, I see a bunch of different reports I can look at. Let's look at a few of these and see what we can find out about how the API program is running. This first report shows us proxy performance, and we can see how much traffic we've gotten in the last hour or so. And we'll see a few people who looks like they're probably getting rate limited. We see average response time in here. We see traffic by proxy and average response time by proxy. So this is a good overall operational metric, just telling us how our API program is running. So this report shows developer engagement. What we're seeing in here is there's a total of 10 developers, 7 of them have apps, 4 are active, and we've got 1 that's highly active. So this gives us an idea of how engaged our developers are. We can see which devices people are using. This might influence how we support different clients and things like that. So we can see who's on mobile, who's on desktop, and then what kind of browsers they're using. The geomap shows us where people are calling from. So if we click in and zoom in on the United States here, we can see that there's a lot of traffic from California and some is coming from Colorado. This is a custom report that shows us order status format. So this API will return data in XML format or JSON format depending on what type of accept header you send. So if you put application JSON as the accept type, it'll return JSON data. If you put application XML in the header, it'll return XML data. And that was to support some older clients. It's interesting from the company's point of view to see how people are using this. The XML interface is a legacy interface, and we want to see who's still using that. So this gives us an idea over time of who's calling what and what they're doing with it. So we get an idea of what kind of responses people are interested in. And we could look at that trend over time, and it'll show us, we can compare that to a previous period. So this will look at the previous hour versus this hour. We can compare the two periods. So you can build custom reports in Apogee to do anything you want. You can grab data that Apogee stores, and you can grab anything out of the request to response and build your own custom report for that. So using these analytics reports, building your own custom reports gives you some good insights into how your API program is running.
Okay, thanks. So what Keith showed you was not only what does an API look like as the consumer of an API, but what does the API product manager actually do? How does that API product manager keep track of who is using the API and control that? So now I want to talk a little bit about the technology under the covers and what are some of the technical considerations you have to put into place if you want to successfully offer an API for lots and lots of people. So it all starts with digital consumer management, or really the management of who's consuming your API. You could just call this API management. And what we find in the industry is that a lot of people know the terms API management and a lot of people know the terms API gateway, and they use them interchangeably. And actually, when we talk about API management, we're talking about this thing here that Apogee has used many times in the past that we call the digital value chain. But the really important thing about this from our perspective is that this is about managing the relationship between the API producers over there on the right who are creating that API, those product managers, architects, engineers who have created the API. And then over to the left, the API consumer, that's the actual developer who is building an app, otherwise known as a digital experience, that's going to use that API. So API consumer management is all about managing that relationship. So what Keith showed you in the demo was he showed you both the API consumer side of that relationship as well as the API producer side. What does it mean to actually be a person who manages an API? And then later on in the next demo, we'll get into the details of how do the API presumers actually use an API management product to make all of those things happen. I'll talk about a few other technologies that are really, really important here as well. One of them is OAuth. OAuth is, I know we're jumping into technology all of a sudden, and this might seem a little abrupt, but this is a really important part of API management because what's happened in the industry over the last 6 or 7 years is that OAuth has become the standard for API authentication. It's not just a de facto standard, it's an actual set of IETF standards, which makes it a real standard, and it's used by almost everybody. Whenever you are using Google or Facebook or Twitter or maybe not Amazon, but almost everything out there, whenever you get to one of those pages that says sign in, or anytime you do sign in with Google, sign in with Facebook, sign in with GitHub, you're using OAuth. OAuth was originally designed to solve a browser single sign-on problem. But OAuth since then has actually been used very often for mobile authentication and for authentication of all kinds of devices. And the reason it's important is because at the end of the whole OAuth process, what the device ends up with is a token, which is a bit of stuff that may have some structure to it or might just be a set of random numbers. That some sort of gateway, which I have down here on the bottom, an API gateway, needs to actually authenticate and decide whether or not to allow access to the API. And then how that token is produced can now vary depending on the business requirements. So for instance, it can be as simple as popping open a form where you type in your username and password, or it could involve two-factor authentication, physical security tokens, consent screens, those screens we all know and love that say, hey, do you give application X the permission to see your email address and look at all of your friends? That's all the OAuth protocol, and related specs like OpenID Connect make all of that stuff happen. The important part about this is that we have a couple of parts of OAuth that are there. One of them is the API gateway, which actually enforces you have to have a proper token in order to access these services. Another is what's called the authorization server. Products like Apogee can act as an authorization server, but so can many others. And then API management is a really important part of OAuth, because what technologists don't understand right away is that OAuth is not only end user authentication. It's Greg using my API. It's also application authentication. Greg is making an API call from version 7 of the iPhone app for the package tracking API and for the API product named Package Tracker. That allows the API product manager to know who's using the API, and it allows the people responsible for security to know things like, an app popped up on that we didn't know about that's creating a lot of traffic. Or we accidentally pushed out a bad release of the app. It's got a problem. You have to take all the API calls from that app and wrap them and send them off somewhere else. Or, worst case scenario, a developer signed up for the API. They're using the API in a way that's inconsistent with our terms of service. We have to stop that application from using our API right away. These are all things that happen a lot in the world of API management, and they're possible because the OAuth authorization server is very tightly coupled with the API management system. Another thing happens a lot on APIs is the idea of a quota. Quotas are, were part of the very first public web APIs, and they exist because if you're going to let people you don't trust use your API, you have to have some way to control how much they use it. Otherwise, they can cause big production problems for you. You don't want to be in a situation where someone signed up for your API, and if you have no OAuth, you might not know what application is using the API, but even if you do without a quota, you don't want them to drive API usage to such a point that it produces denial of service for your other customers. Now, there's a whole range of traffic management strategies you have to put in place when you put an API on the internet. DDoS, for instance, the kind of classic TCP distributed denial service attacks that we all have heard about from botnets, those actually to a certain degree have to be handled at the network level, at the IP level. And the big cloud providers, for instance, have sophisticated technology for this, as does anyone who runs a lot of volume on the internet. Similarly, we have to have things like rate limits in routers and gateways that control, hey, this bit of technology really is going to fall apart if it handles more than 10,000 concurrent requests. The quota is more of a business limit. It controls which application is allowed to use the API and how much. Without a quota, you can't really have self-service. You can't let just anyone sign up for your API if you can't control how much they use it. And it's not only because people might do nefarious things, but also because you need to protect against people making dumb mistakes. Hey, someone accidentally pushed out a version of the API. Whenever it sees an error, it retries immediately with no delay. Great, if you have a quota, at least you can protect yourself from that kind of API, from that sort of bad access pattern. Similarly, quota also makes it possible to have business relationships, to have different tiers of service. Keith's API, for instance, he might want to say that, for free you get a very low quota, but if you're a giant website and you're going to be driving thousands of requests a second to the API, you need a quota so that we can control how much you use it. APIs also face all kinds of interesting security threats. Many of these are things that are familiar to you if you've done anything else on the web. But there are some things that might be a little bit unique to APIs we need to think about. So for instance, if you're opening an API up to third party and you're letting your third party post JSON or XML or anything else to you, you're basically letting anyone who can sign up on the internet send arbitrary content to your server. Now, depending on what technology you have behind it and what the format is, that data that can be sent to your server could contain all kinds of things. In theory, it could contain things like viruses, but more likely, someone might try to do something like send you a JSON document that's nested 1 million levels deep, or send you a JSON document with a string in it that's 100 megabytes long. And these kinds of things could actually cause problems to your backends depending on what kind of technology stack they implement and how robust they are. API gateways like Apogee do have efficient ways to reject those kinds of things before they get in. There's other things too, things like SQL injection, things like Google has a service called data loss prevention, which can look at the responses to your API calls and make sure that you're not inadvertently sending out people's social security numbers or credit card numbers or things like that. So there's a whole lot of threats that APIs face, some of which are specific to APIs, and that we want to make sure we address in the API tier as well. And one more thing that comes up, it's not necessary for every API, but it becomes very important in the world of APIs, is the concept of mediation and transformation. And this is where so many companies, we started out earlier on with a slide where we showed that people progressed from a simple point-to-point integration scenario to something that was more sophisticated, where they're building a new platform. But almost everyone who starts out in the world of APIs has some sort of technology already. And if you're in the kind of shop where you can rewrite everything and you can make changes and you have enough flexibility in your tech stack, that's awesome. You could do whatever you need when you need to do it. But people who have built up their businesses over a period of years typically don't always have that kind of flexibility everywhere in their tech stack. So it can sometimes be very important to be able to layer an API in front of other services. And those services may vary in how close they are to the API you actually want to offer. Many businesses have mainframes, and those mainframes aren't going away anytime soon. businesses have SAP, Salesforce. They have SOAP web services that were built in the heyday of the SOAP era. They have Node.js apps that might speak very, very well structured, beautifully structured APIs in JSON. It might just be a mess. The API gateway is often used in order to sort of mediate those legacy systems and transform things. Transform JSON into XML, transform JSON into gRPC, transform JSON into a format that might be easier to parse for the app. An API gateway can perform a very important use case there. Another thing that API gateways do, which is actually even more common, is they act as a virtualization layer. So if I look on my lower right-hand corner there, we have a collection of microservices. And if you're doing microservices the way that people who are really into microservices want to do, the whole idea is that that collection of microservices could have 5 microservices or 50 microservices or 5,000 microservices. And it really shouldn't matter to the consumer of the API how that's done. The whole point of microservices is that the teams that own those services are free to rearrange them and change them and implement them on the technology base they want. And they should be able to do that without everyone knowing about it. So it would be a big disaster if your system made of 50 microservices, was structured in such a way that all of your customers' API clients had to change when you wanted to split that into now 100 different microservices. So one very important thing API gateways do in microservices architecture is they act as a virtualization point. They present a consistent interface, a set of HTTP URIs and verbs, URI patterns and verbs more specifically, that are consistent and stable and well documented and presented to that end user application. And then that API gateway behind the covers can change as the actual technology implementation changes, maybe as legacy systems are replaced with real systems or new systems. In addition, and when microservices or environments are refactored, that API gateway can also act as that virtualization layer. And with that said, I want to talk quickly about Google's API management and API gateway products. Then we're going to get into one more demo. Google, in the world of APIs, if you go to the Google Cloud Console, you'll actually see that we have 2 major product families. Right now, we have a product called Cloud Endpoints. Cloud Endpoints is an API gateway, and it's only an API gateway. The advantage of Cloud Endpoints is that it's small, it's cheap, and it's very well suited for applications where you have very basic needs for an API gateway that you can deploy quickly, especially to Google Cloud, although Cloud Endpoints will run anywhere. Cloud Endpoints can interact with some of the other API infrastructure already built into Google Cloud. So you can authenticate an API call with an API key, for instance, or you can use a service account token, which if you've worked with GCP, you're very familiar with. And it's great for those use cases. We also have Apogee, and Keith and I spent most of our time on Apogee. Apogee is a full lifecycle API management product. It's not only a gateway that can do the various simple gateway things that endpoints can do, as well as a more sophisticated gateway that can even do some of the transformation and mediation things I talked about. It's also got attached with it a whole API management platform that allows API product managers and others to keep track of what API products they've created, tie them to documentation, control who's actually allowed to use those products, what they're allowed to do, set individual quotas for different consumers, use roles-based access control to control what kind of consumers can see which APIs, which API calls they can make, what docs they can see. It's all real designed for the complete enterprise lifecycle of an API program, and that is, I think, in my opinion, equally relevant if you're offering an API on the internet to third-party developers as it is if you're a large or even medium-sized organization that wants to offer internal APIs that are consumed by lots of different teams. And this is actually a picture of that platform. We talk about some of the components of the platform, including developer portals, which are sort of the key user-facing presence for your API, as well as some of the interesting analytics we give that we showed you earlier in the demo, as well as a lot of services, including transformation, security, orchestration, and those kinds of things. One other thing I will mention about Apogee is that Apogee actually has a couple different deployment options. And this is a very frequently asked question, so we like to sort of talk about it in the beginning. The Apogee Edge platform runs as software as a service as part of Google Cloud, which means that the API gateway runs inside Google Cloud. It can sit in between clients and servers really anywhere, and the whole API management platform is run by Google Cloud. However, we offer other options as well. For instance, there's a hybrid option in which you're allowed to have parts of the Apogee gateway running in your data center with the rest of Apogee running in cloud. And there's an on-premises option where everything runs in your own space, managed by you. And that can mean your own physical data center, your own Amazon Web Services account, your own Google Cloud account, your own Azure account. And we've had customers do all of those kinds of things. So with that said, we're actually going to go back to the very last demo. Keith is going to show us some of the details of Apogee and how to use it to actually add API management to an existing service.
So we saw how people call the API, and we saw how people manage the API program and how they build programs and things like that. But how do we get the service up and running? What did we do in Apogee to make this work? So the order service is a cloud function that's running in Google Cloud. And in order to use it, you've got to send in an authorization header. And the credentials for that are stored inside of Apogee. On the left-hand side of this, there's a single-page web application that you saw. It has an API key that was generated by Apogee. And there's a few more mobile applications. All of them have their own API key. That lets me track who's calling. And it does something else. There's a few fields that show up if you're using an internal API key that don't show up if you're using an external API key. And the idea is people inside the company might need to know who the sales team was that fulfilled this order. But that's not something you want to share with the outside people. So when this runs through Apogee, if you're using a particular API key, we'll remove that information. And that gives the right information to the right people. So one URL for everybody and different API products to manage who can see what. So the idea was we want to build a facade on the back end. The fact that this is a cloud function or what's running back there really isn't that important to the experience. And we want to control access to some features. So some of that data we might want to remove. And they only get a small portion of what might be available through a real order tracking system or through a whole ERP system back there. I'm going to put some rate limits on there so that people don't call this excessively and impose some quotas. Internal people can call it a certain number of times and external people also have their own quotas. We want to add caching. So I put a 5-minute cache on here. If somebody checks the order again and again, it'll just grab that from memory and there's a 5-minute time to live on that cache. I wanted to reformat the request and the response a little bit. It's mostly good, but I want to remove a few fields in there. So those are different things you might do with Apogee in a situation like this. So let's look into what I built in here. So when I went to build the API, I started off with an existing service. So this is just a cloud function that I can call, and we'll take a look at what it returns. So we hit the URL, we put the order number on the end of there, and we get back some basic data in here that shows us about the order. So that's nice, and I wanted to control access to this through Apogee. And I also wanted to remove this sales group field, depending on whether you're internal or external. And I also wanted to support XML. The internal service returns JSON, but some external consumers are still using XML, and they wanted to get data in XML format. So here's the API, and this is what it would look like if we consumed it through Apogee. So what we'll notice in here is that that field has disappeared, and we can request XML or JSON. So in this case, it's JSON, but if I send a different header in there, we get back XML. There it is formatted. So same data, but in XML format. And that's going to support clients who are currently living in the XML world. So other things we can do with this. I've got 2 different API keys. I'm sending API key as a URL parameter. And depending on which one I use, I get back an extra field. So this is the API key that's intended for external people. And then if I switch to this other API key and make the call again, we'll notice that sales group shows up. And that was the field that I wanted to hide from outside people. So you can hand out different API keys, and this is personalized. It's going to give the right response to the right person. And I'll show how I did that in Apogee. So that's the data that comes back. Let's look at the actual API and what I had to do to turn this regular service into something that I could manage with Apogee. So let's look at the API proxy that I built to make this happen. So I've logged into the Apogee experience, and I'm going to play the role of API developer. So I have that existing service. I want to manage access to it using Apogee. So I came over to API proxies. From here, you can create a new proxy, but what we're going to do is we'll look at this order status proxy and see what's in there. So there's the backend URL, and there's the URL in Apogee that we're going to call. So we call Apogee. It manages this connection, the request and response flow, and it's going to send it on to here, and then we'll get the response back. So we'll click over here on Develop. And we'll see within our flow, we've got a few different steps. So these different policies do different things. You can configure them to do things there's a whole palette of them right over here. So let's look at what I've added. I've added a verify API key check. So I'm going to look in the request for a query parameter called API key. And that's what I'm going to check for API keys. If we don't send one, we're going to get back an unauthorized error. Spike arrest is going to limit this to 100 calls per minute. You can set that to whatever you like, and that's just to protect our backend. And then we saw in the report that I was able to tell whether somebody was requesting XML data or JSON data. I did that with this statistics collector. I'm grabbing the accept header, and I'm recording that as request type, and then I can put that in my custom report. I've got a response cache in here, and the response cache has a 300-second time to live, and then the key has two different fragments to it. So I wanted to do it off of the URI, and that worked quite well, but then I figured out that I was caching the wrong type of data for the wrong type of person. So it's possible that people send in the same URL, but one of them gets XML back and one of them gets JSON back. So we also have to look at the accept type in the header to make sure we send back the right response and it gets cached correctly. The backend system requires an authorization header. I've got the secrets for that stored in a key value map inside of Apogee. So what this will do is it'll go grab the order status authentication code from the key value map and store it in a variable. And then we set that as an authorization header that we're going to send to the backend, and that lets us in. On the way back, we're going to conditionally remove the sales group, and I've got some JavaScript in there to do that. So this makes a reference to remove salesgroup.js. And right down here, 3 lines of JavaScript, very simple. So we're going to grab the response and turn it into an object in JavaScript. And then we're just going to delete the field sales group. And then we're going to take that object and turn it back into a string. And then we're going to replace the outgoing response content with that new improved response. After that, this will get called conditionally. So based on whether they've had that header or not, we'll convert it to XML or we won't. And then we've got core support in here so that we can call this from the browser. So that's our basic API proxy. It wasn't too bad to build. Okay, let's do some questions.
Someone said restricting application to certain APIs. So there's actually multiple levels of which you might want access control, right? If you're using, for instance, OAuth to protect access to an API, then to a certain degree, it's up to what user authentication system is behind your OAuth as to what end users can use your API. But the thing that Apogee and any API management tool gives you is the ability to control what applications can use your API and which developers can build an application. So you can set controls on who is allowed to build an application for a specific API. You can even set controls in Apogee on, for instance, who's allowed to see documentation for APIs or to find out which APIs exist. There are a lot of things in there based on things we've learned by that.
Right.
We always get the latency question. And the answer is it depends. When Apogee runs as a service, the actual proxy runs in a Google Cloud data center. We have a lot of those. They also happen to be very, very close to Amazon data centers and very well connected. So if your target is in the same region or very close or in the same geographical area, then it depends on what you do with the policies, but it's no more than a few milliseconds plus network latency. If your data center is on an aircraft carrier in the South Pacific being connected by satellite, then it's going to add a lot of latency.
Sure, and so when I was writing, just as an example, this demo, I had a cloud function running on the back end, and I was seeing about 300 millisecond response time, and that was just network between me and the data center. And I saw that cut in half once I added caching to it. So if you add caching, you may find that the performance can be drastically increased because we don't have to talk to the back end at all. So a few strategies to deal with that.
Exactly. Someone asked about cloud endpoints. I should actually talk about that, and that's a big part of my life. Cloud endpoints in Apogee today do different things for different customers. So for instance, cloud endpoints is very handy for sharing an API with other Google Cloud users. And runs at a low cost, is easy to set up, does a fairly limited number of things. Apogee is a full-featured API management product with a whole bunch of complex enterprise features like we've been talking about now. Over time, both cloud endpoints and Apogee come from the same company and the same group of people. So over time, we're going to make those things work together more seamlessly. Exactly what's going to happen and when is not something I can talk about right now. But if you are using cloud endpoints, we'd actually love to hear from you as well, because we're trying to get some customer feedback. Again, right now they serve different purposes for different kinds of users, and we want to make sure that we respect all that.
Thanks, Greg. There's a question here. The person is asking, we worked in the past with a two-layer model where we had an API gateway on the edge communicating to an internal API gateway that did mediation, composition, and so on. Where's Apogee fit into this? So is it okay to put these two things together? So you could certainly use Apogee as a simple gateway on the outside. It can also do a lot of this mediation stuff. So you saw when I use a JavaScript policy in the demo in there to change the request to response, do dynamic routing. A lot of that can be done in Apogee. And it's really an architectural choice about where you do that and how that fits into your organization. People like that they can quickly build things in Apogee. I would say if you've got full-blown business logic that's long-running and complicated, put that behind Apogee. If you've got something that's going to be stateless and dynamic that's related to returning the right format or something like that, that's great to do in Apogee.
So I was asking about baseline security controls. Do you have baseline security controls developed for Apogee in VSI and Kubernetes? I don't know what VSI is, but I will say that we have a security reporting thing that we're working on, and I don't actually know. I think it's alpha.
Yeah, it'll do a report on
but I mean,
what you have implemented.
In terms of your use of Apogee, if you're a customer, we'd love to talk to you more about that, because we're looking at basically how do we tell you as an Apogee customer, hey, you have security policies about use of TLS and things like that, and you're not following them in this particular API proxy, and you can use that to help make sure those things are being enforced.
Great, thanks. So that's all the time we've got for questions today. I want to remind you that, speaking of security, there's a Gartner report in the Resources tab, and it's entitled How to Build an Effective API Security Strategy. And you can download that through the Resources window or on your screen. Thank you so much for attending today. We'll see you on the next webcast.